This is Talada Jashan, BTech BSB third year. This is my biomaterials assignment 2, where we see the use of biomaterials in a clinical application and how it is used. So, as a continuation of my assignment 1, I've chosen lipid nanoparticle as a biomaterial. Now I'm going to explain how is this biomaterial is going to be used in a clinical setting. Lipid nanoparticle, as the name suggests, it's a particle made of lipids, where it's of four types of lipids, where it combines with nucleic acids, and by use of microfluidics device, it will form a lipid nanoparticle as an encapsulated thing where the nucleic acid is inside. By using which we'll make it travel through the tissue of interest and make it goes into the cells or tissues by a process called endocytosis. And the making of this and it all involved a huge research of 20 plus years, and the clinical application of drugs have only been seen in the recent years. So generally we know that cell has RNA, and RNA produces antibodies which would go and kill the viruses. But what it turns out that our body doesn't make coronavirus antibodies to able to go against the virus. So we need to, if the mRNA of the antibody for the coronavirus, if it somehow is in the cell, it can produce those antibodies and it can kill the coronavirus cell. So, but how can we get the mRNAs into the cell? But if you keep the mRNAs in the bodily outside the cell space in the body, they get destroyed. How? There are RNases inside the body, all where they'll degrade it, or the ribose, the RNAs, the ribose has 2 dash OH bond, which gets hydrolyzed easily, and there is immunity clearance, like immune cells all wanting to degrade the RNA, which makes traveling of this RNA into the cell or tissue of interest makes it very difficult. So that's where we use the lipid nanoparticles, where we use our nucleic acid of interest into the LNP and where it delivers to the tissue of interest. And we said LNP, uh, what is it made of? So LNP is made of four four particular components, which is cholesterol and ionizable cationic lipid, structural lipid, and piezo lipid. What is each one? So this is what gives its fundamental property. So this anionic lipid, it's where it gets positively charged at low pH, and that pushes all the negatively charged mRNAs or nucleic acids inside it, where the ionizable lipids are outside. And along with this, cholesterol would be there, which would fill in these gaps and reduce leakage and enhance the particle stability. And the structural lipid also exists, which will help in formation of the famous bilayer structure. We know these are amphiphobic molecules, that is hydrophobic and hydrophilic ends are there for these molecules. This is hydrophilic and this is hydrophobic, and that's how these molecules are. And we have PG lipids. These are like tail-like substances which go in, and these will make sure that these lipid nanoparticles once formed don't get aggregated in a single place as a big ball. so that individual lipid nanoparticles exist and they act to the clinical application to the way we want, and how it's been used in clinical setting. So the first FDA approved after years of research was a drug called Onpattro, where it's an siRNA encapsulated lipid nanoparticle where it targets to go to the liver, and it stops the formation of this protein called uh, transthyretin or ATTR. Generally, the life expectancy is 3 to 4 years, but if we use this IV fusions and use these siRNA encapsulated lipid nanoparticles and stop this protein getting produced for every 1 to 3 months, and it's been clinically produced some magnificent results. And one more famous example that we all been listening is the famous coronavirus mRNA vaccine. Like we know coronavirus is made by mRNA vaccine, but what is the mechanism? It's the same mechanism that we've seen in the lipid nanoparticles. And the drugs are Comirnaty by Pfizer and Spikevax by Moderna. These both are lipid nanoparticle based to deliver the mRNAs of the SARS-CoV spike protein inside the human cell and makes body receive the power to fight against the coronavirus. Thank you so much.